Hello, good evening, everyone.
Good evening, sir.
Okay,
Good evening, sir.
okay. So yeah, today now the week three is going on, and Professor have discussed little bit about the GPIO, General Purpose Input Output. So now we today we I have some plan to that hands on the real board. So as we will start from the very basic. So last if you have joined the last session. So I've discussed the basic about that board and that IDE and some documentation. So today we'll use all these things and we'll check how we can write the codes on the real hardware to perform some task. Okay, and we will check the all ways. So how we can use the that abstract layer to write a short code to perform the same task, as well as we will also see how we can write the driver level code. Okay, so this is totally hardware level code. Okay, so the experiment target is simple LED blinking. Okay, but we will see how we can perform this on the board with the different way. So let me share my screen. Okay, so yeah, I hope this walkway simulator is introduced to you. Anyone can confirm in any live session or any time.
Yes, sir, we are familiar with the workpiece.
Okay, okay, fine. So as you know, we can start with the that walkie simulator. So that as discussed in the previous session, we will use the Nucleo series that microcontroller. So here we have also that ST and Nucleo some model C031C6. So that we will select, and after that, okay, just let me check. Someone raised the hand. Okay, not. Okay, so you can see this is the board. Okay, here we can connect some that on the simulator we can connect some virtual component. So and after that we can also write the code, and then we can verify this so it is working or not. So this is the option where we can add the component here. So like suppose we want to connect some LED. So here we select the LED, and after that, yeah, if someone have any query, please ask the query. Okay, because I am not able to see the meeting screen. So one of the LED,
Hello, sir.
yes, yeah, please.
Sir, this is from the third week. This content from the third week, which you are explaining.
Yeah, this is yeah, you can expected this. This is from the third week. So now the week till week two, professor have discussed little basic about the embedded system. Okay, second week is just about the requirement like C programming concept. And third week where professor have discussed like this content, GPIO uses, general purpose input output microcontroller. What is this? There is one more topic we have, that serial communication UART. So regarding some experiment we will discuss in the coming live sessions. Okay.
Sir, this is this is my first live lecture. Previously, I didn't able to attend the class.
Okay, so no problem. In last my session, I just discussed about the C programming things, basic about the microcontroller little bit. Okay, so that what microcontroller we can use. So today we will discuss from the very basic of only for the programming. So last session, I just discussed the IDE. So what software we used for this microcontroller,
Okay.
STM.
Sir, there are recorded session.
Yeah, all are recorded. So all are available on the YouTube. You can
Thank
watch.
you.
Okay. So, one second. So this week you can see serial communication. This is also one topic which we will we will perform some experiment on this UART in the later session. But today we will discuss about this GPIO and will perform some task on this based on this. Okay. So now like this portal. Okay, so when we open this, so that by default some code is coming inside this editor, you can see. Okay, this is not increasing, font is not increasing for this. So here on the right side you can see the microcontroller, where you can add the component on this by this clicking on this plus sign, and on left side you can write a code for that. Okay, so here I have selected this LED light. We can connect this LED light so that sorter pin of the LED that is actually represented the ground pin. Okay, so we will select that pin and we will mark where we want to connect this. Okay, so so we can select like this. So ground we have connected. Another pin we can select like any particular pin. So I'm connecting on the D13. Okay, so this is all things are the virtual thing. So we are connecting this. After that we can write a code for that. We want to simply blink this LED. Okay, so some duration it will be turned on, and after that it will be turned off. So this is the first part, void setup. So this is the actually Arduino style coding. This is also just provide some predefined function where we need to pass the parameter, and the uh, it this code will be converted into a driver level code, and then that code will actually perform on real hardware. So Arduino code basically provide a hardware abstract layer, so that only provide the predefined functions. You need to just pass a parameters, and internally that all these hard abstract layer code will be converted into a hardware level code in the detail. So then our code will perform the task, required task. So let's set up part. So there are two parts of this code that I'm removing this, and another part is loop. So setup part basically where we want to do some initializations. Okay, so we want to do some initialization. We want to set some mode for the uh, our component like this. So we can set some initializations. So that initialization will be performed only one time. Okay, when our code will run. But another part we have for loop. So loop basically that will run infinitely. Okay, so our actually in for microcontroller our task actually perform inside the loop. So our microcontroller continue perform that part. So we can that our microcontroller continue will be perform some specific task which is written by the code. So for like, so suppose if we want to blink this LED, okay, so we will first thing we will initialize the thing. So we will set up the pin, which pin actually we are using for the output. So what we are doing here, so we have this D13 pin. Okay, and this is the ground only. Okay, so ground have the some ground voltage, and D13 actually we pass some positive voltage. So that voltage will be formed on the 1 and 0. 0 means no voltage, 1 means high voltage. Okay, so high voltage means approx 5 voltage. So that will be passed to the 13 pin, and then the circuit will be completed and this LED will turn on. After some time we will that change the state of this D3 pin to 1 to 0. Okay, high to low state voltage. So then it will be turned off. So these things we will perform in the code. So first thing is the setup thing. So here there are some predefined functions, so that we can write like pin mode. So that is coming by if you are typing something, that will come automatically. So pin mode, and pin mode, which pin we are using for the output, so that is 13 pin. So 13 pin we will write like a first so here two parameter we have to pass, pin number and which mode we want to use this pin, input mode or output mode or input pull up. This is also one another thing, but we simply want to use as a output. Okay, so that we are just passing some output to the LED. So that output we will select here. So now this pin is actually configured as a output pin. Okay, now inside the for loop we will simply update the output on this pin. Okay, so that means we will update the output 1. After some time, we will update the output 0. Okay, so in this way, that voltage will be passed to the LED, and this LED will be turned on and turn off.
Sir,
Yes.
Output means we will giving the current from the board, and input means we will taking the current inside the board. This means
Input means something like we are passing to the board. Okay, we are giving to the board. Okay, here we are getting something from the board. Okay,
okay.
output means. So suppose input you want to pass some voltage. Suppose if you want to set pin to high or low like this by some pin. Okay, suppose you want to make this pin as a input pin. So for input you have to pass some voltage for this.
Okay.
Okay, so you can just pass 5 voltage, then it will become a high, then just remove it, then it will become a 0. So like this, that will become a input. So we are giving some voltage to the board, that is input. We are getting some voltage from the board, or some output in another form, that is the output actually. Okay, so here we are simply getting the output for the LED from the board. We are not giving any input for this.
Okay.
So what we will do, so we will update this pin. Okay, so we will update this pin. So what is the function for that is digital read and digital write. Okay, so these all are the some predefined function we have. So we will use digital write. So we want to write something on that pin. So write means 0 and 1, this thing we want to write. So that 13, so pin number we have to pass. So 13 is the pin, and which state we are actually changing this 13 pin, high or low. Okay, so first thing we are setting to high. Now, so let's run this code and see what happened. So this will take some time. Okay, so because this is online, so it will.
Sir, here digital write means what happens, sir, in the while loop?
So loop digital write is a predefined function in this language. So that actually perform write some data on the register for that pin number. Okay, so let me just explain what happening actually. Uh, One second.
Sir, by default, it is in low mode.
Yeah, it is low mode. Yeah, it is not. You can see LED is not turned on. Okay, so that means it is in the low mode. So what happening actually? Every pin. So suppose we are using D13 pin. Okay, so 13 pin actually have some memory space. Okay, some memory space. So there is one big memory space actually. So like this, and there are lots of memory locations like this, one bit like this. Okay, but there is one memory location, one bit actually is assigned for D13. Okay, memory location. And this memory location, if we write here 1, so that means this 1 voltage will be passed to this D13 pin as a output. If we replace this value to 0, memory value 0, so this output will become a low voltage. Okay, so low voltage, so this will be turned off. So in this way, each that peripherals in the microcontroller have their registers, and each registers have some size like 32 bits. So that I'll also explain in the detail with the STM32 real board. So each registers have the 32 bits, and where each bit actually assigned for some different tasks, and some for a specific pin like this. And we generally only change the data in this registers field to perform the operations. Okay, so suppose we want to perform pass the high voltage for D pin, we need to only update this memory field to 1. Okay, so then it will become a high. If we want to be made this as a low, so that we will update this value to 0. Okay, so this is the only things we need to do in the memory. So we will understand these things in the detail. Okay, so you can see now LED is turned on because this loop is continuously running on the same state. Okay, high. So now this is continuously turned on. So let's, now there is one operation delay. Okay, so some what we want to do, we want to let's make this as a first thing low. Okay, low, and let's run again. So you can see now this is turned off, it will not be reflect. Okay, so let's change this. high, and I'm writing the same function again. So digital light. Now this time same pin 13 but low. Okay, but what will happen? Let's run this. So it's still, you will feel that this is running. LED will actually turning on, because this loop is running very fast, and this high low, this will happen again. So let's see what type of LED behavior is.
Sir, I think this will happen in like AC current. We passing AC current in the bulbs.
No, it's not AC. Here we are actually have the digital things. Okay, so digital output either in 0 and 1 form.
No, sir. Its behavior is like an AC current. By when we see camera, its behavior is like.
Not AC, still not like AC, because yeah, you can see what we are looking here. This is looking like LED is turning on. Okay, but actually LED is turning on, and some very short time this is turned off. Okay, so but for our eyes actually cannot identify that off period. Yeah.
Sir, can we change the time period, sir?
So that actually we will do. So we can pass some delay in between these two operations. So that is, there is one operation delay in this. So delay, and here if we pass like 1000, so this is actually equivalent to approx 1 second. Okay, so some extra brackets are added. Okay, so now what will happen? But we have to also add one delay operation after that. So you can see this will be turned on first, then delay for 1 second. After that, this operation will be performed, then it will become a low, then 1 second delay. After that, again, this first line will be executed. So in this way, this will be blink actually. Okay, so let's run again.
These are seconds, na, sir? 1000 seconds, na?
1000, not 1000 second. This is 1000 means 1 second. So 1000 like a millisecond. Okay, so this period is approx 1 second. 1000 means value. You can see now the behavior is turning on and off. Okay, so in this way we written only this very small code. Okay, but how this actually code is working with the hardware on the actual memories, that things that actually is actually hidden for us. And these type of language actually make easy for our task for us by this abstract layer programming. So only just use these function and perform their tasks. But how these things actually happen really? So let's move to the real hardware. So this is on the walk-v simulation, and let's move to the real hardware now. So this is the IDE. Okay, so I'll also explain two different way here also, because every microcontroller that IDE or microcontroller provide one this type of language, hardware abstract layer. So where we can use this type of function, and we can configure the things also. Okay, by just some graphical user interface. So let's let me I hope you are not okay, you are not able to see the hardware. So let me just scrolling down. Okay, so you can see now in my camera. Okay, so this is actually a Nucleo board which is connected to my system, okay, by the USB cable. And I have this one breadboard. Okay, breadboard, I hope you know, where we can connect the pins, all these things. Some jumper wire we have. Okay, so jumper wire. So this is simply to connect some pin in the breadboard.
Sir, are you
And
showing anything? Sorry.
on my that camera. Okay.
Yes, yes, yes.
Okay, not in the sharing screen. Just look my camera. Okay.
Sir,
So
please exit the screen. Then your screen is visible in the big screen.
Okay, so let me stop things here. Okay.
Yes.
But 1 second. Now you can see.
Yes,
Yes,
sir.
sir.
Okay, so now this is the one board which is connected through the USB, and this USB is connected to my laptop. Okay, and this is actually a Nucleo board of the STM32, and model is G474RE. Okay, some model information is given here. Apart from that, I have this breadboard. Okay, so breadboard is required to that connections for some component, and some jumping wire I have. Okay, so this is just for the connection to LED. I have one is green and one is actually blue. Okay, so both are capable to handle the 5 voltage to turn on off. So these actually components I have. So for the today experiment, I hope this is visible. I am just turning down so you can see. But yeah, you can see these things in my camera. Okay, so but I'll share my screen also for the coding. Okay, so first thing, there are some pin actually here. Okay, so there are some pins for the connection. So similar type of pin we have, which I just saw in the another board on the walkthrough simulator. So you can see there are some pin number is also mentioned. And what I'll do, let me share now screen, and I'll show the pin structure of this board. Okay, so I hope you can see my screen, shared screen.
Yes, sir.
So let me making big. Okay, so yeah, so I'm opening the document for this. So reference document for this board. There are two types of board. We have user manual and that reference manual. Okay, so user manual basically provide the all information of pin structure and the purpose of the each pin like this or in the details. So here you can see this is the actually board. This is the board we have, which I actually just show you, and same model this actually we have. And yeah, this is the pin structure actually. Okay, this is the pin structure we can connect. So this side, this pin actually is for to connect the board to the Arduino board. Okay, so this is actually compatible to the Arduino board, so we can also connect the Arduino board with this board and we'll perform the task. Another thing is this is the simple normal pin for this board. Okay, so now there are multiple pin we have. Now you can see the structure of pin. So here naming is actually different. Okay, so on the board actually this pin naming is given. Okay, so this blue color pin D15, D14 like this, and this pin is actually compatible to the Arduino Uno board. But corresponding that our STM32, that pins are also given. Okay, so D15 is equivalent to the PB8. PB means port B8 pin. So P means port and B is the port name and then pin number. Okay, so in this way we have this pins which actually are represented the actual board pin. But if we are connecting to the Arduino board, so we use these terms D15 like this, these terms for the connections. So we can use this diagram to just understand the port actually. Okay, because on the board this is mentioned, this blue pin number is mentioned D15, but we have to identify the corresponding port pin for writing the code. Okay,
Sir,
yes.
sir, here how many boards are in the figure, sir? Two boards, no?
No, board is only one, but this is the actual, but this is just a pin diagram.
A board above board name is microcontroller, no? Simply microcontroller, sir.
This contain all the things. Okay, so micro processor is also there. You can see this ARM. This is the processor. Other things is also there. You can see this blue color is the push button for the user. This is the reset button. Some LEDs also there that we can use for some of our purpose, and some other debugger is also there. So this is complete microcontroller that contain memory as well, that contain the processor, input output pins, and other hardware type that actually UART, GPIOs, all these things. Okay, so this is the complete that microcontroller board.
Here Arduino is given. That means that is a different board, na sir?
So this is actually Arduino connector. Okay, so here these two pins you can see, these two pins actually. Okay, let me share the Arduino board also. 1 second. Okay, so you can see in my camera now. Just okay, see, this is actually another version of the that STM32. This is discovery model, but here you can see this is now Arduino board, Arduino Uno. Okay, so Arduino Uno, this is also a microcontroller, and this can be connect. Let me just make big this 1 second. I hope this is visible now. So this microcontroller actually connected on this board through this pin actually. Okay, so from this side. Okay, from this side, we have this here. We have some input type of pin, and that pin actually connected on this like okay board. So some setup is required. So like this. Okay. Yeah, you can see now this is connected. Okay, and LEDs also turn on for the Arduino Uno. So we can connect the Arduino board on this board also. Okay, so this is the one feature this board have. Actually, we can connect the Arduino board also. Okay.
But what is the advantage, sir, actually?
So sometimes if we want to perform some tasks which actually compatible to the Arduino, okay, so that we can simply connect through this. Okay, some like a communication things we are using two different devices, and we want to communicate in between through some communication, so we can connect. Okay, so this is just a compatibility. Okay, so sometimes if some project is created on the Arduino and we want to use this for some additional things.
Sir, can we connect a flash drive to the H32 board, the board which you are showing in the screen?
No, yes, some that connector are required. We can connect the additional components definitely. So, but flash drive means you want to connect memory.
Yes, sir. Sir, hard disk, flash.
So that is depends on how you are using. So you need some compatible drivers or all these things to connect.
Sir, the previous one you shown, that is Arduino board, and it is useful for communication, na sir? Any communication?
Not communication. This is also capable to perform many tasks. This is also a microcontroller. Okay.
Sir, is there any limit that this board support a particular language? What are different languages this
No,
board supports?
Arduino supports that language which is defined for this Arduino board. So that is actually very similar to the C language. Okay.
Arduino language, na sir?
Arduino language have the specific language, but which is actually very similar to the C.
Okay.
Okay. Yeah. So this is just a board. This is also a microcontroller, but here in this course we are looking for this STM32. So this is also one microcontroller. So okay, I'll check this. So now on my other screen you can see this complete structure, and now this is the pin diagram we have. Okay, so now we can just map the pin, which pin number is actually denoting for the Arduino pin. So you can see this mention also. Okay, the Arduino Uno compatible pin. This blue color pin are Arduino Uno compatible, and this ST, this is STM32, which is actually STM reference pin. Okay, so this is pointing to the that ARM processor pin basically. Okay, so we can understand this mapping through this user manual, and let's see how we can start the project and how we can start the connection. So here, first thing, the GPIO, this is one type of peripheral, and this peripheral we can connect some input output component. Okay, so some component for taking the input, some component for just giving the output. So as per the name, general purpose input output. Okay, so GPIO. So we can use these pins as a GPIO pins, and but we have to understand that which pin we are using as a GPIO. So now suppose we want to turn on the one LED. Okay, so we want to turn on the LED, and you can see this pin G and D. Okay, so G and D, this is the one pin we have. Here you can see this on the right top, G and D, corresponding G and D also. So this is for ground. Okay, now just below this there is one pin D13. Okay, which is mentioned in the board, but corresponding the name for the STM32 is port A, pin number 5. Okay, pin number 5, but on board this is printed actually D3. So we will just use this pin D13 for output LED. Okay, so now let's configure this, or we can also make other pin. I'll also extend the code for this. We will use two LED. We will connect another pin also. So here I am using this G and D for ground, and PA5 corresponding D13 pin for the output. Okay, so now first thing, let's connect this. Okay, so I am connecting now. You can see on the board. So I am taking the ground for this pin, ground, and I'm connecting this on my
Sir?
breadboard. Yes.
सर एक डाउट है, जो ब्लू कलर की जो आपने नेमिंग करी है वो एक्चुअल में बोर्ड में लिखा होगा, और जो ब्लैक
हाँ,
कलर
हाँ,
की
हाँ।
नेमिंग है वो नहीं लिखी होगी.
यस.
ओके.
ओके, सो इस बोर्ड पे एक्चुअली जो ब्लू कलर है वो मेंशन है, ब्लैक वाला नहीं मेंशन है. तो हमें इस मैपिंग के थ्रू समझना पड़ेगा, क्योंकि हम कोडिंग एचटीएम में करने जा रहे हैं. ठीक है,
और ये सब यूजर मैनुअल में दिया होगा.
हाँ, ये जो मैनुअल में दिया हुआ, किसी किसी बोर्ड में जैसे कंपेटेबल नहीं है अगर आर्डिनो से, सो उसमें ये नहीं होगा इस तरह का. ओके,
ठीक है.
Sir, could you please explain 1 second a pin configuration in this figure, for right side diagram, sir?
so this pin is just actually because this board is compatible to connect through the Arduino Uno board. Okay, so what naming actually we used in the Arduino Uno board, compatible pin naming is also given. Okay, so that D3, D01, this naming which is also given on the STM board is actually referring to the corresponding Arduino Uno board pin. Okay, but the other black color naming is actually representing the naming pin naming for the STM32 board. Okay, so this port B, port C, for the configuration and everything we will use this name if we are only working on the STM32 board, this board. Okay, we are not using the Arduino for the connection this.
Okay.
Okay, so now let's I'm adding this. So I am connecting this ground pin in my breadboard. Okay, in the one connection. Another is that D13. Okay, so D13 is just a next lower pin, and that represents a port A, pin number 5. So I am connecting that pin in another side on the breadboard, and now I'm connecting this green LED, one for the ground and another for the that side. Okay, so that D13 pin. Okay, so now this is just a connection, simple. So this is the physical LED now. So I have connected this, and after let's see how we can write a project and code for this. So there are two way actually. Let's open the IDE, and we will see. First thing is the hardware abstract layer way. So let's create a new project, new. Okay, and this is the new option is which is coming, and here we will open the STM32 project. Shall I zoom this screen, or it is fine, it is visible?
We can zoom from our end. we can zoom from our side also.
Okay, you can also join. Okay. Hmm. So, yeah, 1 second. So now this actually interface opened when we create a new project, and here we will select the board. So board selector option is coming. So we will select the board here. Okay. After that, with this manual, you can see there are lots of model number is given. So we will select our model. So that is actually G74RE. Okay. This is our model. We will select after selecting here. Then we will select the board on this side. Okay. Just click in this, and after that next. Okay, if you don't have the documentation of this board, you can download from the above side. Okay, doc and resource data sheet large picture, you can click on that, and it will actually, you will be able to download the corresponding document for this board. Now next, you will see this interface is open. This is just a project name purpose. Okay, so what name we are giving? So let me giving one name. So SEP 2024 term and experiment 1. Okay, and this is just a LED and using UI. Okay, so UI. And let test one. Okay, and this time I am selecting this targeted language C, and targeted binary. This is executable. We will just perform on the board. So this is executable. And another is targeted project type. So we are selecting this STM32 cube actually. Okay, so this is provide a UI to configure the board pin actually, and it will also generate a code. So let's click on this without changing any option. I am selecting this finish, and it will automatically create the files.
सर इसका मतलब ये है ना कि हम लोग सी लैंग्वेज में कोड लिखेंगे, वो STM32 में कन्वर्ट हो जाएगा इस IDA के थ्रू.
Yeah, so actually by this option, it will automatically create some code for us. It will also provide some user interface to configure our board for some pin output like this, and automatically code will be generated. We need to write a very small part of the code. Okay, so let's open that, and then I'll explain. After that, there is one option is coming on this like this, select software components. So by default, this added sub this pin for some specific purpose. So actually we are removing this, and okay. It's, it's take some time. Okay, so now you can see. Huh. So this one user interface is open here. Okay. Now you can see what was the pin actually we want to use as a that output pin. You can see D13 PA5. Okay, so PA5. This is the port A pin number 5. Okay, so this we will read the output from this pin. We can also change the pin. Okay, so that I'll also discuss. Suppose we want to read the output from that PB the D5. Okay, so D5 corresponding port is P, port number port is B, and pin number 4. Okay, so we have to select this pin. So all these pins you can see in this IDE. You can see. So let's zoom this. So all pin are actually coming here. Okay, so you can select all the pins and you can configure that for the purpose, what purpose you want to use this. So here you can see this PA5 is already available here, and this is green actually. Okay, so by default we can change the state for the reset state, or we can change for some another purpose like GPIO input. Okay, so that is become a input pin now. Okay, and now GPIO output if we are making, so we are, our purpose is GPIO output. Okay, so now we are using this pin as a GPIO output. Suppose you want to use another pin as the output, uh, which is actually I discussed is PB5. Okay, so you can click on this and you can make this as a like GPIO output. Okay, so now you can see this also becoming green. Okay, so and reset, you can click on the reset button and it will become a in the previous state. So in this way you can click on the pin and you can select the mode of the pin, which mode actually you want to use this. Okay, now in this way, because in this project we are only just reading the output on this pin, so no, we are not updating anything here. And here in the there are many options are coming. Okay, so these things we will understand later, the timer things and connectivity, that communication things. Okay, so basic things are this system core. Yeah, so one thing is RCC, that is actually a clock. Okay, so that clock is actually connected to the every part of the board. Okay, and that actually provide the clock frequency to the every part of the board. But by default it is actually disabled for many of the part to just save the power for the board. Okay, so if we are using any specific part of the board, so first we have to enable the that RCC clock for that part. Okay, so we will select this RCC and we will enable this crystal. So we have this one oscillator for this that will actually we will enable. Okay, so this is now we have selected this option. Let's keep as it is, and after that we will not doing anything and we will just save it. Okay, so just control S, and when we will click the control S, you can see it is asking for do you want to generate code. So we will click on this yes. Okay, so now it is generating the code. That means what configuration we have done through the UI. So requirement, configuration, initialization, all will be done. All will be code will be generated automatically. Okay, so you can see this code is generated, and there are lots of things are done here. So you can see this RCC related some settings are configured, and this is also some configuration is done. Lots of things are actually by default created. Okay, and here there is one part of the code, so you can see include main. This is the one thing, and later here we can see inside this is the main function. Okay, of the program, and inside this there is one while loop we have. So we need to write the code only inside this while loop. What we actually all configurations are done, we no need to set up anything here. We only write a actual purpose of the our task. So we want to just turn on the light LED which is connected on our port A, pin number 5. Okay, so what we will do inside this while loop, so this is the while loop where the one means this is the true, so that means this while loop will run infinitely. Okay, so now we will write a code so that here we have some predefined function which is actually for the STM32. So that
Sir, could you please explain what have you done on HTM32 regarding connection, sir?
so regarding
Previous
connection,
slide.
if you see this interface UI, okay, so this is automatically open when you create the project in that default mode. So here we have this interface of the pin actually. Okay, so let's close this. So you can see on this side, this is the actually pin structure we have. So which pin actually we want to use as a output mode, so where our LED is actually connected. Okay, so that pin we will select. Okay, so that pin we will select here. So by default this actually PA5, there is one LED on the board actually. Okay, so that LED is also connected on this pin as a output. Okay, or we can also connect it something as I connected my physical LED. So I'll see you on the board also when we will turn on this. So what we are doing actually, we are just using this pin number as a GPIO, general purpose input output mode. Okay, we are selecting the mode of this pin, which type of purpose we are using here, this pin. Okay, so we are using this pin as a output pin. So now this is the one selection we need to do, which pin we want to use as a output. We will just make as a output mode. Okay, after that, nothing, we are not doing anything on this on that configuration. After that, we will just enable the clock for this port. Okay, so this is actually port A. Okay, so this port A is actually connected on some part of the microcontroller. So for that part, actually, we have to enable the RCC, that clock, okay, pulse. So in that case, after that, that part will actually start working. So we are just enabling this clock by this selection, so that high speed clock SC. So we will just enable the that this crystal, this option. Okay, so by this, our clock will be started for this part. Okay, port A. So now this is I have done. After that, I'll just click on the save option, Control S, and that then it will ask to generate code for that. And after that, we will click OK, and then main file will be opened. Okay, so this file.
Sir,
Yes.
can you please explain again? My network's lost. So this clock part.
1 second. So where is the ID? Okay. So that clock part is basically there is one option inside this system core. Okay, so system core.
Okay. Yeah.
We will select this RCC option,
Okay.
and we will just enable. By default, this was disabled actually. Okay, so we will just select a oscillator for this, select crystal oscillator. So that will actually generate that clock pulse for this port, what we have configured. So that initial setting we have done only, and after that we will save it. Control S.
Sir, here in for the functioning of this STM32, sir, we have to select any supply voltage, ground, anything, sir?
No. By default, 5 voltage is now coming to this board, and all the power is actually it is managing. We no need to enable or disable any bolt here. Okay.
Sir, here on the as in the square shape, sir, 4 sides, sir, different things are given. What are that, sir? 4.
Which side?
Top, bottom, right, left, sir. In the screen, STM32, sir.
This
Right
clock.
side, right side. No, previous slide. Yeah. Yes, this figure. What is this, sir?
This is
VDD,
this actually a actual pin of the board.
physically look like this, no, sir?
No, not look like this. So physically, I have already seen that microcontroller is look like, and that is given our some pin actually to connect. Okay, configuration. But here also we can see all the pin. Okay, but in the virtual form. Okay, so that is actually representing that we have all these pins set, and which pin we want to use for some which purpose actually. Okay, so we can select on that pin only. So we are configuring our pin of the board for some specific mode. Okay, mode means what is the purpose we want to use that pin actually. Okay, so each pin you can click on any pin like PA8. So PA8 pin is also given on the boards in some place. So you can see PA8. So PA B is here. Now, it is the PA8. Yeah, you can see this pin. Okay, so D7, this one. So PA8 is the pin. Okay, this pin is actually given in IDE. This. Okay, so PA8, this one. Okay, so we want to use this pin for which purpose, so that we will select by clicking on this. Okay, so we are using this pin as a input mode, output mode, some timer mode, or some that analog to digital converter mode, and that some other purpose. So there are lots of things are there. So RCC, MCQ, some options are there. So which mode actually we want to select this pin. So we are only selecting this by just clicking from the mouse. Okay, and corresponding code will be automatically generated. We will not do anything. Okay, so we are simply clicking on the pin and we are selecting the mode for that pin, and we are saving the our configuration. After that, automatically this C file will be generated. Okay, so main.c, you can see this file is now generated automatically. There are lots of code is already there, and this is just a configurations on the hardware. So which what is the purpose of the pin? You can see GPIO pin is selected here. What is the mode is selected, so that is actually automatically generated. Okay, so here this is difficult to understand also. This code is actually for some microcontroller purpose. So some driver is already predefined, that some code is already predefined and corresponding code is generated. We will only write a code which is actually will perform the specific task with the help of this STM language. Okay, so that STM32 language is actually a hardware abstract layer. We generally call as a HAL. Okay, HAL layer. Okay, so that language we will use here. So for this language, we will use a function, predefined function. So we want to write some output on the pin. So that is one HAL. Okay, so that HAL we will write in the type okay, in the capital letter, and we will press the control and space. Okay, so now all operation of this HAL will come as a reference. Okay, so but we want to use a GPIO write pin. Okay, so that one function is there. So GPIO, so PIO. Okay, so you can see GPIO, there are many functions are coming here. So GPIO write pin, this function we will use to just write a data on that pin. Okay, so same things we are doing which we have done in the walkv, but now this is the functions are different. Okay, now here we will select the mode. Okay, so which port actually we are using. So GPIO, first option is port name. Okay, so GPIO A, so we are selecting the port A. Now GPIO pin. Okay, so GPIO pin, which pin we are selecting, so that we will select like this. So PIN and underscore, we are selecting the pin number 5. Okay, so A5. Okay, so this is a state. Now which state actually we are making this pin? So we are making this pin as a we can write like a GPIO, and you can see options are coming by press control and spacebar. And GPIO like pin reset and set. Set means we will set one value on that pin. Reset means we will set 0 value on that pin. Okay, so set. So set means this will this pin become a high in the high state. Okay, so now this is just for a setting. After that, what we will do, yeah, same things. We have to reset this pin because we want to blink. Okay, blink the LED. So let first, this is the end point, and again I am writing the same things. Now we will reset it. Okay, so RE only, so reset it. But same things, we need to pass some delay, otherwise we will not see the blinking. Okay, so here for delay function is there, so that function is HAL underscore D, and let's check DEL. Okay, H delay. So that function required some integer value, so that is very similar to 1000. We'll pass here. Okay, now this is the endpoint, and after that again delay. Okay, so now this is the only code we have written here inside the while loop. So this, we are writing a high state on this pin number 5 of port A, and then we are delaying for 1 second, then we are writing again 0. Okay, on the same pin, and then we are delaying. So this is the code we are writing only. Then after that we will save it, and we will click on the project. Okay, so we will click on the project, and we'll click on the right. Okay, right click on this and build project. Okay, so build project, basically we'll check the all things and compile thing. Okay, it will create a file for the controller. So first time it will take some time for the initialization. So you can see now there is no error. So and this ELF file is created for the microcontroller, and this we can upload on the board. So now we will click on the same on the project, and we will click on the run edge. Okay, so run edge, and here we will select this STM32, this one. Okay, so now if you see the board on my that keyboard, so I hope you are able to see. Okay, so here two yellow light is turning on. So let's now clicking on this run as, and then this one option. Okay, now you will see uh, yeah, some. Okay, so one option is more coming, so let's okay on that.
Sir, here why we have written in user code end while, sir, not in user code begin, sir? Could you please explain?
1 second, yeah, just uploading this. You can see one red light is blinking. That means our code is uploading on this board.
Yes.
Okay. Mm. Okay, over LED is actually removed. You can see. So now LED is turned on or off. Okay. So now there is one more LED on the board also. Okay. So I think this is not visible, but if you can see on the board, yeah, on the board there is one LED is also
Yes,
turning on or off on the board itself. Okay. Apart from this green LED which is connected on the board. Yeah. What was your question? Someone is asking.
Sir, why have you written the code in first case? That means user code end while, not in user code begin, sir. At that portion, sir.
No,
Could you
we can
please-
write anywhere. So this is not. This is just a comment. Okay, this is just a comment. You can just write any place. Okay, inside this while loop. So this is the opening bracket. This is the close bracket. Okay, in between you can write any place, or you can also remove this.
Okay,
सर
sir.
हम लोग का जो कोड है वो 20 to 30 लाइंस का है, पर बहुत सारे कमेंट्स है तो इसलिए 100 से ऊपर लाइन हो रही है.
हाँ, so और बहुत सारा configuration भी है. Okay, so you can see this is a default configuration which is generated by the by automatic. Okay, so this configuration initial setup is automatically generated. Now this complete actually executable file is uploaded on the board, and this our code is working like this. Okay, LED.
Okay.
And let's suppose we want to add one more okay LED on this. So let's open again the configuration. You can see I'm opening the configuration again. Now I have the another LED on my board, so that is actually blue color. Okay, now this time I'm connecting that you can see the diagram. This PB okay, so PB5 D4 I'm connecting this pin. So D4 is the lower side on the board, and I'm connecting on the other line. And this is one blue LED we have. So I am connecting this, and our program is actually still running. Okay, so now you can see this blue LED is not turning on or off. Okay, so what we will do, we will change the configuration, and now on the board that corresponding board that is okay, which one was
PB4 सर PB4
PB4 now. Okay, so D5 is so D4 okay, D4 is now PB5.
या सर PB
PB5. Okay, so PB5 actually here it is given here PB5. So we will select this pin, and we will make as a GPIO output. Okay, so now I've selected this. So RCC is already enabled in this port also. Okay, and we will just click on the Control S. So you can see it is asking to do you want generate code. Okay, so first thing, yeah, let me just generate code again. Okay. So now it is generated again. So other setting is also now configured for the another pin. Okay. So you can see this pin GPIO B is also now okay configured. So again that part is actually blanked. Okay. Now we have to write a code again. So that HAL. Okay. So that option we will check. So now that what was the function variable GPIO. Okay, so PIO, GPIO, and that still we have to write
Right.
more. So W, yeah, right pin. Okay, so this one. Now first pin, suppose first port is now A, and pin number is that we have to write in the capital P pin and underscore that 5 GPIO pin number 5. Okay, and pin state is GPIO and check that is set. Okay, and at that point, so this is for port A. Okay, and after that, at the same time, we will make turn off the port B pin. Okay, so that is actually pin number 5 per port B. Okay, and that will become as a reset. Okay, so but we will use the semicolon here, and after that we will pass some delay, so that HAL underscore D. Okay, so that is delay, not this, sorry. So like 1000. Okay, now we will use the both line again, and we will change the state after this. And one is for here. Okay, so now we will make this as a reset, and we'll make this as a set. Okay, so now you can see the code structure. Now we have two LED connected, and now first time we are making the green LED turn on and blue LED turn off. Okay, after delay that will state will be changed for that. So in this way we will run this. So that we control S, and then we will again build the project first. Okay, so build project, it will generate a new binary file for the controller. And after that we will run. Okay, so now we will upload on the microcontroller. So now you can see again our microcontroller is now blinking and our LED is turned off.
Yes.
Okay, and let's see what state is coming. You can see now this board,
Yes.
one time green and one time blue LED is turning on. Okay, so according to this code. So in this way we can configure the code, and we can write this way of the coding, and that is okay. Now move to the next way of the coding, that is actually totally hardware level coding, and we will use totally C syntax, C code here. Okay, so that you should know how the actual code is working behind this code, okay, which we are writing here. So now again create a new project.
Sir, I have a doubt.
Yeah, yes please.
Hello.
Yes, please ask.
Now if we'll close this software, the STM32 ID, the microcontroller is still working, or
Yes,
it should be
it
connected?
will work. Yeah, it will work. Okay, now our code,
Now
that
means-
binary file is uploaded on the board. Okay, so doesn't matter what we are
Okay.
doing with the computer.
So it is
Yeah, it will work.
Sir, by pressing
okay. So it is saved in the
reset
memory
button.
of microcontroller.
Yes, correct.
Sir, by pressing the reset button, it will delete the code.
No,
in
no,
the
no,
file.
no. Actually, it just start the things again. Okay,
Okay.
just like a reset
So if
the
we-
computer things.
Yeah. Yeah, sir. If we have to means the reset the memory of this controller, what we have to do for that?
So you have to
Now to
just
remove the code,
you
the
have to
file we
upload
have
the
to-
empty file. Okay, so suppose just what you can do, you can remove
Okay.
this main code completely and upload that.
Okay. Yeah,
Okay,
yeah.
so that will
Okay.
reset the memory.
Sir, the same thing we can do in the ADLM kit. the same thing, this experiment.
So you can do with any microcontroller, but you have to understand the pin structure, all these things for that controller. Okay.
Hello, sir.
Yes. Yeah.
The ADLM kit
Sir,
is only for.
Sorry.
हेलो राजकुमार, कुछ कह रहे हो आप?
Yeah, so I'm saying that the ADLM kit is only 4 GPIO pins.
So right now we are looking for GPIO only. So we will also see the other purpose like interrupt timer, UART, that communications, these things. So that purpose we can also use PWM. We have one pulse with the modulation. So that task we will also perform in the coming sessions. Okay. And you will also see some experiment in the physical lab in the campus. Okay. So some with the sensors.
hello,
सर,
sir.
हम लोग का जो लैब वर्क होगा वो सेम इसी किट पे होगा, सेम इसी बोर्ड पे होगा?
सेम इसी बोर्ड पे होगा या कुछ मॉडल चेंज होगा, वो भी जैसा भी होगा वो उस टाइम बता दिया जाएगा.
Yeah.
सर ये
It was only STM, no?
ST, we are only using the STM board. Okay, but model may be different.
Sir,
Okay.
could you please show how it is saved and done, sir? Please show.
So for saving, so let's just what project we have created. So okay, so what current project we are doing. So we will click on that project, and first thing, if we are updating anything, okay, on the board, sorry, on the that code, so that we will click on the build project. Okay, build project. So that is the compilation process, and that actually generate the binary file. So this, you can see this experiment led test1.elf. This binary file will be generated. So that file is basically will be upload on the controller board memory. And for uploading, you have to click again on the project, and then you have to click on the run as. Okay, so run as button, and then that STM32 this application. Okay, so you can see on the board now the blinking is started. That means our code is uploading on this board. Once code will upload, our task will start perform on the board actually. Okay, now we can remove, we can turn off our computer, doesn't matter. So our code is running on the controller, not the computer. Okay.
Yes, sir.
Hello, sir.
Yes.
Can you please explain like the GPIO pin 5 and GPIO A and B? I got that set and reset part, but that pin.
So GPIO, what GPIO?
5.
What you are asking? So GPIO just a port. Okay. So here you can see GPIO. So GPIO means general purpose input output. This is a one type of this is a one type of peripheral on the microcontroller. Okay, so we can use some pin, some port or pin for some general purpose, like it just passing the output, just reading the input like this. Okay, so there is no specific purpose. You will see later some pin for the specific purpose also. That is just a PWM, some communication, and some interrupt like this also. But this is actually GPIO is only for the general purpose input, reading, and output. Okay, so we have many pins, and that pin we can use as a general purpose pin. And you can for that also you can also see the memory structure. So let's open the reference manual, and inside the reference manual, when we click on the system and memory overview. Okay, so system and overview. Okay, this is the open. Now in this structure, so complete memory layout is given here. So now you can see there are many type of peripherals here. Okay, so this is actually, you can see this column in the document. This is actually all our peripherals, which are actually connecting to the processor. So now some are like DAC, okay, digital to analog converter, DAC, you can see ADC is there, GPIO. Okay, so these are the ports we have like this. Okay, so GPIO, G, F, E, like port. Okay, so what are the registers range for that each port? So GPIO A registers range start from this memory location and to this memory location. Okay, this is the address in the hexadecimal form. So that I'll also explain in the next code. So this is memory mapping for each part. Okay, each peripherals is given in this manual, and that is required if we are working on the driver level code. Okay, RCC, you can see if you want to enable the RCC, so we can also see the memory representation and we can use that. So in this way, complete information is given here. After that, I'll also explain by the code. Okay, so this now we will use this document. Okay, reference manual for the next hardware level coding. Okay, so I hope till here this is clear how we can use this type of coding. But you have to understand each type of function before using this. Okay, so you have to search the Google or like some, you have to read the documentation if you want to use the HAL, all these type of functions. So what are the purpose of each type of function? And end of this course, I'll also explain that how we actually can create the driver file which we are using actually. Okay, so in the IDE, you can see inside this folder there are many files are created. So there is one driver actually, you can see here. Okay, so driver folder is there. Inside this STM32GA HAL driver. So this driver is nothing, this actually contains the lots of code. Okay, C files or header files. And what function we used in our main? Okay, so that main function, you can see this HAL GPIO write pin. Okay, so this function where it is actually defined, all these functions are defined inside these files. Okay, so these files are created for each part of the microcontroller, like GPIOs, it is created. You can see one file gpios.c in this. Okay, so all function related to the GPIO are actually defined inside this. All function related to the timer are defined inside the time C. So driver are actually predefined code which are actually direct interact with the hardware of the microcontroller, now which is predefined by the that STM32. And how we can create this, how we can also generate our drivers, so that we will discuss at the end of this course, how we can create these files, what is the structure we can use to create this. Okay, so that we will also discuss later. So now let's move to the next that coding from the scratch. Okay, without using anything. So now let's move to the again create the file, create the project and new, and then STM32 project. Okay, so again we will select the board. So this is the same interface we are selecting, board selector we will click. After that we will select the board name. So G74RE, that I have this C474RE. We'll select this and next. Okay, now again it is asking, so like say 2000, you can give any name. Okay, so I'm just giving for my information, so term, and this is like experiment 1 underscore and LED. So without using I. Okay, so I'm just writing a dot test one, not dot, sorry, underscore. So I'm just giving this name, and this time I'll just select this empty. Okay, so target project type is empty. Okay, so it will not open anything, any UI or anything. Okay, this time we will write everything from the scratch. Yeah, so this actually we need to understand how the things will be opened. Where it is created. Okay, term experiment. Okay, so this project is now created. Let's remove all the previous file. Okay, so just for removing the confusion, so this is the previous main file we have. Okay, now the new project file folder is created here, and some predefined folder is created. So inside the source, src source, and there is one main.c. We will click on this, and this is only a like a empty file. Some predefined very small code is there, but we can remove that also. Okay, so that this is the comments that we will remove, and this is one a int main. So this is totally empty file we have. Okay, now we will start just understand that each part of the code. So stdi int, this is one library. I hope you have watched the video lectures where professor have discussed. uh, Generally we use the data type like integer. So integer takes 32 bits, okay, or sometimes you use the like sort, so that takes 16 bit, 2 byte. So but it is also depends on the machine to machine. Okay, so maybe sometimes if you are using sort, it is taking on 16 2 bytes on the one machine, but it may be change in the different machine. So what we will do, actually we will use some standard things. So that is one library. Here we will use the type where 32 bit, if we are using 32 bits. Okay, so that will remain same on the each type of machine, 32 bit. Okay, that will not change actually, because on the microcontroller if we are using any type where on one machine that is using taking 32 bit, and we are working according to that. But if we are using the same code on the another machine, so now the same data type is maybe taking less bit, so that may be create a problem for another machine. So we will use some standard, so our bits will remain same for our data type. So because of that we will use this uh, standard std int, okay, in the for the microcontroller. So here we will just only use that number of bits which actually is required. Okay, not more than that, because here our concern is the memory, because we have the limited memory on the microcontroller. So now first thing is the our target is same. Our connect all connections are there in the same way. We know the port number PA5 and PB5. Okay, so now we will start working here in the main function. So first thing is, as I mentioned in the reference manual, everything is assigned like as a address. Okay, so each peripheral, each part of the board is actually connected through some bus channels, all these things. So first thing is you can understand the memories. So what are the memory and where is actually it is started from this diagram, memory mapping. Okay, but you can also see the details. Okay, so first thing is like this ahb. Okay, so these are actually called as a bus. So let's see where, if anywhere is complete diagram is given, so that is actually will show you. Not in this. This also not given. Okay, so I search that some structure is given how the connections are actually happen through each component of the microcontroller actually. Okay, so I'll search that and we'll see in the next. Okay, so some memory structure is given. So actually there are two types of memory. One is code memory, okay, and another is a RAM. Okay, so code memory where actually our code saved. Okay, so we upload our code and that code actually remains in the microcontroller. If we turn off the microcontroller, still that will remain stored. Okay, so that is called as a flash memory. Okay, another memory we have as a RAM, random access memory. So that is actually run the code. Okay, so that is required for the running the code. So the one memory is type of a like a permanent memory, another is a volatile memory. So here, so this is actually AHB2. This is a type of bus where all these peripherals are connected. So bus is similar like some channels. Okay, so some buses are there, and each bus some components are connected. Okay, like this. Okay, so each type of bus actually name is given. This AHB1, AHB2 in this way. So what components are connected? You can see all these list. Okay, so what are the peripherals which are coming in this category? So all these peripherals are actually connected to through this bus.
So bus is like a wire.
Yes, wire. Okay, similar to the wire. Okay, but it is actually a printed circuit board, so all are connected through some that predefined lines. Right. Okay, not the actual wire here, but this is actually some circuit level things.
Okay.
Okay, so all these things are like you can see DAC, DAC1, DAC3, all these GPIO1, all are connected on this bus PAHB2. Okay, and each peripherals have some memory starting range and end range. Okay, so you can see this is the starting memory range and end memory range. And what this memory range actually store, because each peripheral have some registers. Okay, so registers are simply a memory. So like if I talk about GPIO, so GPIO have like many registers like 8 to 10. So each registers have 32 bits space. Okay, so that is a start actually like this first address is like 48000000. Okay, this is the starting address of first register of this GPIO A, and this actually takes 32 bits. So 32 bits means 4 hexadecimal, we can see that. So that ends on like this 48000000 like 4. Okay, so or we can say the last address of this next register will be start from this 4 location. So just add 4 byte. So 48000004. This is the location of next register. Okay. So 32 bits means we will add 4 byte in the each address previous value. Okay. So previous value was 0. So next register will become at the 4. Okay. So that is actually 04. Next register will become at 08. So just add 4 byte in the each registers. So that is actually a new register address. Okay, so and each registers have 32 bits, so that means it is taking 32 bits total, and each bits have some specific purpose. Okay, so like this addressing is given for each type of peripherals, GPIO and as well as the RCC, that clock. Okay, we will enable that. So now we will use this addressing memory mapping things, and we will write our code, and we will note down the address of each part which we want to use in our code. Okay, so that is actually we will start from the writing the code. So and we'll see what we will use. Where it is. Okay, so this is the main part. So here now, first thing is we need a clock frequency enable. Okay, we want first things, if we want to use any GPIO, we have to enable the clock frequency for that. Okay, so first things we need the address, and we will use some that variables for that. Okay, so we will use some variable, we will give some name. So uint, and this is the simply a type. Okay, 32, because each we know that each registers have 32 bits, so at least we will use the variable data type 32 bit. Okay, and int t. Okay, so this is just a type inside the standard library. This is stdi.int.h. Okay, we'll give some name for this so that we will make as a pointer. So pointer that p and this is for RCC. Okay, so p port C, no, not port C, or we can take like a port clock. Okay, so RC. Okay, so RC, not RC, R clock, we can say that. Okay, clock, you can give any name which you can understand. Clock control. This is just a variable name. After that, we will write a starting address of the clock. Okay, so where we can see the address of clock, so you can see there is one RCC which is connected on the, one second, ABB2 HB1. Yeah, you can see this RCC. Okay, so this RCC is connected here, HE1, and the starting address of this is just copy this 4002 and 1000, this one. Okay, so so let's copy this. So we will just note down the each address, Control C, and we will enter into our code.
Sir, here, what is UINT32, sir?
This is a data type. Okay, this is integer UINT, and this is just a data type declaration which is defined inside here. Okay, like integer, we generally use int. Okay, in the C code.
Yes, sir.
So we can also use here that int, but for safety purpose, we generally use this library stdi.int, where if we can
I think,
define
sir,
the data
you
type.
means unsigned integer, na, sir?
Yeah, unsigned, yeah, correct.
And
Okay,
32 means
unsigned
32.
integer, yeah, 32 bit. So it will always take 32 bit on any machine.
Yes, yes,
Okay.
sir, for safety purpose,
Huh,
because
so
different
it-
machine has different.
Huh.
And is there any meaning for underscore T, sir?
Uh, mm, T.
Sir, I think it's a variable.
No, this is not a variable. This is a type actually name.
Okay.
This
Correct,
comes
right.
under the type, yeah. So I'm not sure what is the actual meaning of this, but yeah, it is actually a type which is defined inside this library. We will always use this underscore T. Okay, so I'll check this what is actually specific purpose for this underscore T, but this is similar to your int, actually int, sort, char, that type. Okay, but here actually this will always take a 32 bit. Okay, so now this address we have assigned to this, but because this is given as a hexadecimal, so we have to perform the typecasting for this. Okay, so for typecasting we have to convert the type for this address. So we will perform the typecasting for this like this. Okay, and this column. So this is now one variable pointer we have created that actually take the address of this starting address of RCC. Okay, let's check the addressing of the RCC. Okay, so which actual address contain the RCC for port A? So that we will go more in the deep in the documentation. Okay, so let's go to the RCC section in this. So just check that where is the RCC mentioned. Okay, yeah, this one RCC, you can see 7 point, and here RCC registers. Okay, just click on this, and now so we are actually looking for this AHV2 port. Okay, GPIO port. So just see where it is mentioned. So GPIO port AHV2 APV1 AHV3 AHV2. Okay, what will be peripheral HP, HP3, HP, yeah. You can see peripheral clock enable registers. Okay, so we want to enable the clock for peripheral for this actually AHB2. So just click on this. Okay, because our port is actually connected on AHB2 bus. So here you can see that this AHB2 peripheral clock enable registers here, and this is a one registers actually. Okay, it takes 32 bits. You can see the range of 32 bits, 0 to 31. Okay, each bit actually is have some specific purpose. So you can see GPIO AEN, GPIO BEN. So if suppose if we set this. Okay, so this register, okay, which actually offset value is 4C. So offset means we will add 4C value in the initial address of the RC register. Okay, so that we have noted down in our code. So we will add this value in that. After that, this registers will actually pointed out. And in this registers, we have 32 bit. Each bit have some specific task. Some are actually empty. Okay, no purpose. But here you can see first bit. This bit actually a GPIO A port EN enable. Okay, if we set this value as a 1, it actually become a enable. Okay, it we will set as a 0, it will be disable. Okay, so now we want to set this bit as a 1. Okay, now starting address we will not update over here for this registers in our code. So we will add 4C. That means at this place 4C. Okay, so now at this point we will update our first bit to a 1. Okay, so that we will discuss how we will update this. So this is the one point we need to update for the enabling the clock frequency for the GPIO port A. Now another we need a pin actually. Okay, so that we want to turn on our LED at pin number 5 port A. So we will write the same type of memory mapping. So now this time this is for port actually. Okay, so P port A, and we want to enable this. Okay, so mode enable. Okay, mode enable. We are giving this name only, mode enable. And what is the address of this port A? Okay, port A. So what is the starting address of this? So again documentation, and see the same memory part. Okay, so you can go to the system and memory, and so where actually GPIO address is started, you can see this address. Okay, so 48000000. This is the starting address of this port A. So we will use this 4800. So 4800 and 0000. So this is the starting address of port A, and this is also a starting address of the first register of this port A. And so let's go to the registers of this. So that again documentation, and we'll see GPIO now this time. So just see that GPIO document is general purpose input output. This is the peripheral, and inside this registers. Okay. So first registers, open this. Now this is the 00 offset. That means we will not add anything. So at the first address is actually a first register address. In this address, we want to use this pin. Okay, so you can see mode 0 means pin number 0. Okay, mode 1 means this 1 is representing a pin number actually for this GPIO register. So total we have 15 pin. Okay, maximum. Now we want to set this 5 number pin. Okay, so that means this location we have 2 bits. Okay, and if we set these 2 pins to 00 value, this pin will work as a input mode. If we set this pin as a 01, it will work as a output mode. If we set as a 10, it will work as a alternate function mode. If we set as a 11, it will work as a analog mode. Okay, so here our purpose is to set this as a output mode. Okay, so this is the one task we need to do. We need to update this pin number to 01. Okay, so just we will remember this. So this is the, yeah, someone is have any query, please ask.
Sir, here in the written that mode 15 is to 0
No.
also written, sir. What it means, sir?
No, not mode 15. This is mode 5. Let me increase the size.
In this document 15 also written, no? 15 is to 0, 1 is to 0 written.
So this is actually a pin number 15.
15.
Yeah, suppose if port A have total 15 pin. So doesn't suppose maybe we have this Nucleo board, but maybe this doesn't have the pin number 15 for this port. But some other boards maybe have the maximum total 16 pin for one port. Okay, so now we want to use this pin number 5. So we will only check this part. Okay, so this part is basically you can see 0, 1, 2, 3, 4, 5, and we need to set pin number 11 and pin number bit number 11 and bit number 10 to 01. Then this pin actually will work as a output mode. Okay, if we set this 2 bit as a 01. Okay, so this all registers have like a memory on space for 32 bits, and we will just set a value for that, and that will work for some specific purpose. So this is the one, what mode actually we want to use for that. Okay, so we want to use as a output pin. And now if we are using as a output pin, so there is one another registers that is actually a output the data actually. Okay, You can see input data registers, this, but we are not using it as an input pin, but we are using as a output data registers. Okay, so for that pin, we are actually using as a output data. So we will use this next register for the same port, and that is the offset 14 value. So we will add 14 in the initial address, and after that, which pin actually we want to update. So that is actually this one, 5 pin. Okay, here we will set 0, so our pin will become low. If we set as a 1, our pin will become a high. So this is actually output, okay, to the pin. So now these two registers we need to set this value. So okay, how we set this value, how we reset this value, so that things we will done by the bitwise operator. So that we have discussed in the previous week. Okay, so let's first also note down the address of, so the first register is, this is fine, but we have also store the another registers, output registers. Okay, so that have the address 14. Okay, that output data register, so that we will also change it pa output data, like, okay, output data. So now these 3 pointer we need to require. First thing is we will enable our clock. Okay, so how we will, so the what things we are doing, we are just we are doing the initial setup. Okay, so this will done only one time, and after that, so we will just run a loop. Okay, so inside the loop we will write a main code. So to enable the RCC for port A, so we have seen that in the registers of the RCC, the first bit is actually representing a port A. Okay, so we want to set. So let's again open that if you have missed. So AHP RCC HAPBO HB2 peripheral, not this, this one. Okay, so you can see this 4C address, this is the starting address, and the first bit, this bit we need to set 1 to enable. So we will do the things. So how we will do this? Okay, so we will use a pointer for this. Okay, so now this time we will use this pointer, and we will just perform a, so we want to set a first bit, okay, as a 1. So what operation we can do? We can perform OR operation. Okay, so OR equal to, and what we will do, we will simply write a like this, left shift, we can 1 or this 0. Okay, so what is the meaning of this? Let's explain. Okay, or operations. Suppose our registers value is like this. I am writing only 8 bit. Okay, so 1 0 0 0 0 4 and 0 0 0. Suppose this is the first 8 bit, okay, of the register. 0 bit, 1 2 3 4 5 6 7, and we have total 32. Now we want to set this bit as a 1. So what we will do, we will perform a OR operation with 1 value. So this is the decimal form. What is the corresponding 32-bit binary value for this? 0 0 0 0 0, like this one. Okay, so last bit will only be 1. Okay, all 32 bits we have, and this is the binary representation for this. And if we perform the binary representation like OR operation with this 1, okay, so OR operation will perform 0 plus 0 or 1 OR operation, it will become a 1, and other will remain same. Okay, what we have the initial, that will remain same. Okay, so all corresponding value are zeros. So only this bit will become a 1, other will remain same for the registers. If we perform the so OR operation, how actually OR operation works?
From and onwards,
sir. So I'm explaining OR operation first. So OR operation means like suppose I'm making the table. Okay, so A B. Okay, and we are performing OR operation with this. So OR operation is work like this: 0 0 0 1 1 0 1 1. So OR means If any input is high, output will be high, otherwise low. Okay. So
Yes.
you can see 0 0 0 output. Okay, so this will be the overall output. 0 1 1 1 0 1 1 1 1. Okay, so this is the OR operation. AND operation we have this B, and suppose 0 1, sorry, 0 0 0 1 1 0 1 1. This is the four possibility. And AND operation is says that if any input is 0, output will be 0. Okay, so 0 0 0 and 1. So this is the operation in the binary. So we will use this OR operation to set the value. Okay, so corresponding, suppose if we have 1 1 0 0 0 like this, and we want to set this bit as a 1 in this previous value, so we will perform the operation OR like this. So 0 0 0, and we will make this corresponding bit 1 and 0, and we'll perform the OR operation between. So what will happen? So this will remain 0 0 1 1 0 0 0 1 0 1 1 0 1. Okay, so you can see all remaining bits are as it is, only this bits are actually changed, set. So okay, so in this way we will decide which place actually we are actually setting our 1 to perform the OR operation. So that what I have written here is 1 slash slash 0. Okay, so this is a left shift, so that means we have the value 1. So one value is just a representation like this, and we are shifting 0 number of times. Okay, we are not shifting any position for this. Okay, if we shift like 2, so this bit will shift 2 position on this. So 0 1 0 0 like this. Okay, so which location actually we want to shift this 1 to enable? So we can just write here how many shift position. Okay, so we, for right now we are only setting the first bit, so because of that we are writing 0 here.
सर
For
अगर
left.
ग्रेटर देन साइन लगाएंगे तो सर क्या होगा?
No, this is actually a left shift sign. Okay, and this is a right shift sign. Okay, and if you are using only this is now a conditional statement. This is not a, this is a totally different type of operator, relational operator.
सर तो इनिशियल जो प्लेस होती है वो हमेशा लेफ्ट से स्टार्ट होती है, उसके हम लोग राइट कर सकते हैं या लेफ्ट कर सकते हैं?
हाँ, so what actually you are taking here, this is a 1. So what is the correct, this is the decimal value. Okay, corresponding binary value is 1 and all 0 initial this. Okay, if you are taking 32 bits, so that means 31 bits are 0, and 0 time you are shifting. Okay, so 0 times this will remain same. Suppose sometimes you need to make some bit as a 1 1. So how you will do this? So what is the corresponding decimal value for this is 3, correct?
Okay.
Okay, so what you will do? So for 3, the value is like this. Okay, so 0 0, and last bit will be 1 and all remain 0. Now we want to set this 2 1 1 bit on some specific position, like this position. Okay, so how many points we need? 1 2 3 4 5 6 required. So we will write like this only, this 6 times. Okay, so this part actually will be shift 6 times to this side.
Okay, sir.
Okay, so corresponding that bit we will set actually to the 1 position. Okay, so you can just decide your bit position where you want to actually set in the registers. So in our code actually you can see 1, this is, and we are not shifting any position, so that means the first bit actually will be performed OR operation with the actual value of that registers. Okay, and that part will be updated to the 1 value. So in this way our clock will be enabled by this line for this GPIO port. So this is the first step. We have enabled the clock for port A. Now this part is done. Now second task is just made this mode to output data. So for output data, as I mentioned in the documentation, this, okay, registers, port A, this one. Okay, so we need to set this. Okay, we need to set this 11 pin and 10 pin. Okay, so to 0 and 1 mode. Okay, so how we can set this 10? So initially what, suppose we have we need to set basically this. Okay, but we have to reset both first as a 0. 1 second. So both first as a 0, and that is actually 127. Okay, so first thing what we have to do actually, because maybe in the previous state this suppose this bit is actually set as a 1. Okay, and we have to set this bit as a first bit as a
सर आपकी आवाज ब्रेक हो रही है।
okay. My pen is not now running. Hmm. One second. Just give it. I think
हेलो राजकुमार,
हाँ
भाई आ गया समझ में सब कुछ
क्या
जो सर ने समझाया?
अभी का तो आ रहा है भाई।
भाई मेरे को तो वो क्या कर रहे हैं एंड वो समझ में नहीं आ रहा था कि बीच में कौन सा सेकंड बिट वो क्या कर रहे हैं।
बिट मैनिपुलेशन वाला वीडियो देखो भाई, सर का बिट मैनिपुलेशन वाला वीक 2 का वीडियो
भाई वही समझ में
सब सर का।
कैलकुल भाई तुम्हारा नाम हेमंत बोल रहे?
हाँ हेमंत है भाई।
हम लोग शायद लास्ट टाइम लिनक्स क्लास में मिले थे। लिनक्स लिया था ना लास्ट टाइम में तुमने?
हाँ क्या बोल रहे थे भाई?
लास्ट टाइम में तुमने लिनक्स लिया था ना?
क्या लिनक्स? हाँ लिनक्स लिया था मैंने।
इस बार भी लिया है ना शायद?
हाँ मैं रिपीट कर रहा हूँ।
हाँ लास्ट टाइम हम एक बार हम तुम्हारे साथ ऑनलाइन क्लास में ज्वाइन मतलब थे लिनक्स तब देखो। कोलकाता से हो ना भाई?
हाँ आप कहाँ से हो?
लखनऊ से। मिले थे हम लोग। उसके बाद तुम्हारा मेरे पास रोल नंबर नहीं था या मोबाइल नंबर भी नहीं था, तो कुछ टेक्स्ट ही नहीं था।
कोई दिक्कत नहीं भाई, डिस्कॉर्ड से कोई दिक्कत नहीं, व्हाट्सएप ग्रुप भी है ना, दिक्कत नहीं।
व्हाट्सएप ग्रुप वही वाला ना जो जर्नल पर्पस वाला है?
हाँ ये डिस्कॉर्ड भी ऑफिशियल है, कोई दिक्कत नहीं।
क्यों भाई सर आएंगे या फिर
नहीं?
टाइम हो गया तो निकल लिए?
अब तुम्हें समझाना है भाई। समझाओ।
हेलो
अब अपनी स्क्रीन शेयर करो और समझाओ हम लोगों को।
जरा
सर
यार
सम-
थोड़ा सा समझा यार।
अरे देख, बिट मैनिपुलेशन वाला तो सिंपल सा पार्ट है। और ऑपरेशन कर रहे हो क्या
थोड़ा
किस बिट
स्क्रीन
को
से
सेट करना है, मतलब किसी अगर
आकाश भाई तुम कहाँ से हो?
हम्म?
आकाश पटेल बिहार में।
जानते हो?
मैं यूपी से हूँ भाई।
हाँ भाई लग रहा है।
यूपी वाले मिलकर दोनों।
भाई यूपी की राजधानी से हो?
नहीं भाई, प्रयागराज से हूँ मैं।
भाई
ये
खतरनाक भाई।
देव 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 में
जरूरी नहीं है भाई
अरे
खतरनाक
वहाँ
रखने।
वहाँ
आकाश
से
कैसे हो भाई? आकाश
मस्त है भाई, मस्त
भाई।
है। अपना बताओ।
हाँ भाई, आपसे
अच्छा
बोला
ये
था दोबारा ना।
अबे
क्या
अच्छा
चीज
ये
बोला?
बताओ, समझ में आ गया सबको जो सर समझा रहे हैं?
भाई अभी बिगिनर हूँ, यूट्यूब पर
नहीं सर ने तो आधा अधूरा कोड सम हेलो,
हेलो
ये
बोलो।
सर आधा अधूरा कोड लिख के भाग गए, कुछ बस सेट रिसेट किया है, तो क्या करना है आगे?
अच्छा ये वही जो पहले जो सर ने किया था यही सी प्रोग्रामिंग को लेके कर रहे हैं ना? वही जो पहला कोड लिखा था, पहले ऑनलाइन
हाँ
लिखा
हाँ
था फिर ऑफलाइन लिखा, अब ये सी प्रोग्राम से
हाँ।
डायरेक्ट लिखा।
नहीं हाँ, वो अलग अलग लैंग्वेज थी। जो
अरे
पहली लैंग्वेज थी वो ऑर्डिनो वाली
रिकॉर्डिंग
लैंग्वेज
चल रहा
थी।
है ना, रिकॉर्डिंग ऑन है शायद ये।
अरे होने दो यार रिकॉर्डिंग।
नहीं रिकॉर्डिंग क्या दिक्कत है भाई, सर है ही नहीं। नहीं मैं बोल रहा हूँ जो पहला वाला कोड दिखा था ना सर ने, पिन मोड वाला।
सब लोग कैमरा ऑन कर लो भाई।
कैमरा ऑन करने देते तो नहीं आ रहा है, तो कितना नहीं आ रहा है, लेकिन
इस क्लास को
जो
ऐसा
पहला
बनाओ
वाला
कि जैसे वो है, मतलब अपने क्लास रूम में बैठे हो अगल बगल।
अबे
ये
मैं तो क्या बताऊँ यार।
अच्छा
अबे
मैं ये बोल रहा हूँ
ST
जो पहला कोड दिखाया था ना,
बोल रहा हूँ
फेमस हो
कि
जाओगे राजकुमार, ऑन करे रहो। यूट्यूब पे आएगा ये तो।
भाई मैं बोल रहा हूँ कि STM32 अल्टरनेटिव क्या यूज कर सकते हैं, कुछ पता है?
हाँ?
दोबारा बोलो भाई।
STM32 के प्लेस पे हम लोग कोई अल्टरनेटिव यूज कर सकते हैं, क्योंकि बजट में वो काफी हैवी लोड करता है, मतलब काफी वो मतलब अधिक प्राइस का है ना।
सर ने कहा था कोई भी इस्तेमाल कर सकते हैं, पर उसका ये जो यूजर सीट है और एक और कौन सी सीट बताइए, ये तुम्हारे पास होनी चाहिए और इनको समझ लो तो कर सकते हो।
नहीं, इसे तो हार्डवेयर जरूरत है
भाई
भाई। सिमुलेशन से काम हो जाएगा ना।
हाँ हो जाएगा भाई, लेकिन ये जो सर बता रहे हैं बिना STM32 के न्यूक्लियो बोर्ड लगाए के बिना हम लोग नहीं
अब
सेट कर सकते
स्टिमुलेशन
ना।
क्या होता है भाई?
सिमुलेशन मतलब वो सब ऑनलाइन में मैंने एक्सपीरियंस है।
अरे वॉकवी के मतलब बोल रहे हैं ना, वॉकवी यूज करते हैं ना हम लोग को। अगर प्रैक्टिकल नॉलेज चाहिए तो उसका जरूरत पड़ेगा, कोई
भाई भाई
अल्टरनेटिव।
कल क्लास आपने किया था एम्बेडेड सी का हुआ था ना कल?
हाँ हाँ,
उसमें
कल
क्या
क्या
पढ़ा
बताया था? हाँ कल हमने भी ज्वाइन नहीं किया था।
सीरियल मॉनिटरिंग बताए थे, फिर उसके बाद ट्रैफिक लाइट वगैरह बताए थे, उसमें थोड़ा सा नॉर्मल कोड था।
मैंने वीक 2 का ना कि वीक 1 कैसे कुछ है
हाँ
क्या?
नहीं, उसमें वीक 1 2 का वगैरह कुछ नहीं है, वो अपने से बताए थे। वो सीरियल मॉनिटरिंग कैसे कर रहे हैं, कैसे हम लोग DX RX को यूज कर सकते हैं, ये सब बताए थे।
तो
पिंस है ना।
ये रिकॉर्डेड लेक्चर। हेलो आकाश,
हाँ हाँ
ये रिकॉर्डेड लेक्चर मिलेगा क्या कल वाला, मतलब कहीं पे है क्या?
हाँ है ना, यूट्यूब
सर
भी।
से मैंने पूछा था, सर कह रहे हैं रिकॉर्डेड।
कहाँ
भाई
पे
यूट्यूब
मिलेगा
चैनल है,
ये?
रुको मैं भेजता
इसी
हूँ।
इसी के ऑफिशियल चैनल पे मिलेगा क्या, BS इलेक्ट्रॉनिक्स के?
आप सुनो,
सुनो,
एम्बेडेड सी में डाल देना लिंक व्हाट्सएप ग्रुप पे, ठीक है?
नहीं नहीं
मैं डाला था भाई,
इसकी चैट में
मैं
डाल दो
बहुत बार
यार,
डाल चुका हूँ।
इसकी चैट में
मैं
डाल
बहुत
दो।
बार डाल चुका हूँ।
ढाला हुआ है यार।
सुनो सुनो, इसकी
मैं डाल
चैट
दे
में
रहा हूँ,
डालो। डाल दो
रुको
हाँ।
रुको डाल दे रहा हूँ।
अच्छा आकाश भाई एक चीज ये बताओ, सर वीक वाइज पढ़ा रहे हैं कि अपने मन से आगे बस समझा रहे हैं डायरेक्ट?
अगर देखो भाई, ये जो सर पढ़ा रहे हैं ना, ये हम लोग को लैब के पर्सपेक्टिव्स पढ़ा रहे हैं। और
अच्छा
जो प्रोफेसर नितिन सर जो हैं, वो हम लोग को कोर्स के अकॉर्डिंग पढ़ा रहे हैं। तो हाँ, दोनों का
अच्छा
पर्सपेक्टिव अलग है, लेकिन हाँ मतलब वो बोल सकते हो तुम, कोर्स कंटेंट सेम ही है, थोड़ा सा डिफरेंस हो सकता है बस हो गया।
अच्छा, ये लैब स्पेसिफिक पढ़ा रहे हैं जो लैब में करना है।
ये हम लोग प्रैक्टिकल वाइज बोल सकते हैं करना है ये
यार
लोग
तो जो ये लेक्चर्स ज्वाइन नहीं कर रहा है, मतलब बहुत सारे लोगों ने एम्बेडेड सी होगी, आज मैक्सिमम लोग 13 या 14 थे, तो वो लोग तो लैब शायद कर ही नहीं पाएंगे,
नहीं
मतलब अच्छे से।
भाई मैं आदित्य से बात किया था उसमें क्या है
आदित्य
कि
राव।
हाँ उसमें क्या है कि अगर तुम्हें कोड आता है मतलब कोडिंग करना आता है तो तुम लैब वगैरह कर लोगे आसानी से। अगर कोडिंग वगैरह नहीं आता मतलब बोल सकते हो बेसिक अगर क्लियर नहीं है तो थोड़ा दिक्कत हो सकता है। तो वही
अभी तो
बहुत से
ये वाली
लड़के तो
कोडिंग किसको आती होगी, ये बिट उससे मैनिपुलेट करना होता है रजिस्टर, ये वाली कोडिंग इसी में सीख रहे होंगे लोग, इससे पहले किसी ने सीखी कहाँ होगी।
हाँ वो तो है। ये भाई थोड़ा इसका अलग वो है ना कोड वाला में से मतलब ये पहले क्या नाम है एम्बेडेड सिम लिखता है फिर ये अपने आप उसमें क्या नाम है सी में सी जो होता है हेल्प करता है उसे हार्डवेयर लैंग्वेज में कन्वर्ट करने में फिर उसके बाद कहीं वो हार्डवेयर समझता है तो ये प्रोसेस थोड़ा लंबा है
अच्छा ये
आकाश,
बताओ, किसी को बिट मैनिपुलेशन आता है तुम दोनों में से?
हाँ थोड़ा बहुत मुझे पता है लेकिन उतना भी नहीं।
समझा सकते हो अभी यहाँ पर?
हम्म, भाई रुको कैसे
वीक
समझाऊं यार।
वीक 2 में उसका कोई प्रोग्राम है ना, ग्रेडेड असाइनमेंट वाला।
हाँ खोलो 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 मैं बताता हूँ कैसे करना है मुझे।
रुको खोल रहा हूँ, एक मिनट।
भाई सर ने आज जो जो स्क्रीन दिखा रहा है सब कुछ अवेलेबल है ना उसमें हम लोगों में सप्लीमेंट्री में ना। HTML32 का जैसे आज पढ़ा रहे थे ना HTML32 का उसको कहाँ कौन सा लिंक है वॉकवी का कुछ लिंक है क्या?
ये नहीं नहीं ये जो सर बताया था तुम्हें सॉफ्टवेयर ना ये भाई तुम केवल तभी यूज कर सकते हो जब तुम्हारे पास सब HTML32 वो होगा हार्डवेयर होगा मतलब हो सकता है
भाई
कि
उसी दिन करना होगा, जब 2 दिन की लैब होगी उसी में सब करो।
इसी इसीलिए मैं बोल रहा था कि कोई अल्टरनेटिव है क्या क्योंकि भाई बिना उसके ये सॉफ्टवेयर काम ही नहीं करेगा।
अच्छा
तुमने
सर जो वेबसाइट से सब चेक कर रहे थे जितना डाटा सीट था ना मैनुअल फैनुअल जो भी है HTML32 का लिखा हुआ था वो सब के अगर हार्डवेयर हम लोग के पास होगा माइक्रो कंट्रोलर होगा तभी हम लोग उससे कर पाएंगे ना।
हाँ बोल सकते हो
अगर
मतलब जो
नहीं
ये
होगा
दिखा
तो वॉकवी पे करना है ना।
हाँ करना है लेकिन वो जो होता है ना जो प्रैक्टिकल वाइब जो होती है वो नहीं मिल पा रहा है वो वही लैब में ही मिलेगा।
ठीक है ठीक है ठीक है।
अभी ये इन्फिनिटी क्या होता है बे? आ जाता है जब देखो तब।
हाँ ये क्वेश्चन ना
हाँ?
ये थोड़ा
हेलो।
लगेगा। हाँ
हेलो।
ये सर
Hi, am I audible?
सर आ गए, सॉरी सर।
No problem. Actually, my laptop is totally heated, so it is hanged. Actually, I am not sure why. So now it is.
okay. Sir, can you explain bit manipulation by the beginning? I mean, by the beginning, so that anyone
Ha
can
ha
understand.
ha. That I like actually start. So some students are left it. Okay.
Yeah, but it is recorded, na sir. Then anyone can see
Ha ha
this.
ha. Okay. Okay. So where I was actually. Let me share my screen first.
सर आप कूलिंग पैड यूज कर रहे हैं मतलब लैपटॉप के लिए?
नहीं वो तो है एक्चुअली दैट एचपी का लैपटॉप पता नहीं इसमें पिछले कुछ दिनों से हीटिंग की इशू आ रहा है।
ओके।
तो प्रोसेसर भी i7 है लेकिन पता नहीं क्या इशू है। सो 1 सेकेंड। पूरा सिस्टम हैंग हो जाता है एक्चुअली।
सर आप ये हम लोग के ईएस कोर्स के हैं कि एमएस कोर्स के हैं?
नो एक्चुअली आई एम द इंस्ट्रक्टर इन बोथ कोर्स। ओके सो आई एम teaching some course from the DS also as well as the ES. Okay, so like Python I teach PDSA.
सर लिनक्स भी पढ़ा रहे हैं सर आप?
हाँ लिनक्स भी है।
यस यस।
नहीं सर,
सर
पर एक्चुअल आप ये मैं ये पूछा था कि एक्चुअली आप इस टाइम ये किसी कोर्स में इनरोल हैं डीएस या ईएस में या बीटेक आईआईटीएम के ऑफलाइन कोर्सेस में?
No, no, no.
ओके।
सर कोई वो अल्टरनेटिव हार्डवेयर है इसके ESP32 के अलावा?
Alternative hardware for?
ESP32. I mean, we can use it in respect of the.
You can also use that, but I have never used actually, so I'm not sure about that. Okay, so where I was actually.
So,
Mhm.
So sir, I have a doubt. Now the Arduino board is not very much expensive. So can we use the C language that we are using by the bit manipulation?
No, I think that Arduino will not support the C. Okay,
Okay.
but
It
similar
will
to
only
C, it will support
yeah.
similar to the C. But here STM32, we can write a hardware level coding in the totally C. What I actually am writing now, right now. Okay, so
Okay.
you can
Okay.
see this code. I am not using any shortcut function or all the any type of this. I am just writing all the C code. Okay, and
Okay. So
I
the
am directly accessing
STM.
the memory.
Okay. So STM will support the pure C code as
That
well.
we can also do in the STM this
Yeah.
board. So for
But
beginners, those who want to like learn the driver level coding, this STM32 is the good one.
Sir,
okay.
this is
So जो
available.
हम लोगों
Huh? This is available for.
Sir, this will be available on Google, na, sir. How to get this page, sir?
So it is available. You can search on the Google. You will get, I think, from Amazon or maybe some Rovu.in,
Okay.
DigiKey. There is one website.
Is there any link for this in our course portal, sir?
No, for hardware we have not mentioned any link, but you can easily search. Okay, so that board will be available for Amazon. You can also
Sir,
the cost
Walkme,
is around
Walkme is also
3,000.
give.
No.
approx around 3,000, and this is also model by model. Okay,
Sir, Walkme is given that is sufficient, na, sir.
Walkme is also fine. If you are not able to purchase, then you can practice on the Walkme, and later in the physical lab you can just work on the.
So, sir, this
So
is what screen you are showing. This is only required when there is a physical device with us. Now we have physical
Yes,
device
yes. So this is just a IDE, okay, where we
ID.
can write a code, and that IDE provide lots of feature. Also, we can debug, we can access the memory of the board. Each area we can access through this IDE. So this IDE is basically provided by the STM. So all interface you can easily connect the board, okay, and you can access the memory of the board. You can debug easily. Okay, all features actually are inbuilt in this software.
now, sir, I
Okay.
have a doubt.
Hmm.
Yeah, in the OKV simulator, we can also use this the pure C syntax. The pure means the hardware level coding of C.
Yes, actually you can write a hardware level coding in any place, but you have to understand all the actually documentation for that board.
Okay, okay. So the documentation is also available in the OKV simulator for reading, or it
No,
is.
actually you have to download what actually model is given on the Walkme. You have to
Okay,
download the documentation from STM32 website,
okay,
and
okay,
after that you can write a code on the
okay,
Walkme.
okay. Then it will work now.
That it will work.
Okay, okay.
Okay, but yeah, professor will discuss that about that also. So how you can write a C code on the Walkme. You cannot directly write on that interface. You have to create another file, .c file.
Oh,
Then you can only
main.c
write
file.
that type of
Yeah,
file.
yeah, yeah. That was discussed in week 3. That
Okay, that is discussed. Okay, okay. So let's move to the another part. So that I was discussing this that bitwise operator. I hope this is clear. Any doubt in this? How we are actually changing the state or these things?
No,
no, no,
not
sir.
understood, sir.
It was not understood. Okay. So as I mentioned that in the OR operator is actually this is the operation. Okay. Oh, it is still not connected. Just give me
सर के नेटवर्क लॉस्ट हो गया ऑफिस।
भाई छुट्टी ले लेते हैं क्या सर को बोल के? और
छुट्टी
आकाश
लेंगे
रेस बोल
लेकिन
रहा। हाँ बोलो बोलो भाई।
वो लोग कब बोले कहाँ से भाई, अंदर मीटिंग में हो तो बोले। या तो ऐसा कर सकते हैं सभी लेफ्ट हो जाओ तो सर भी लेफ्ट हो जाएंगे।
को बोलना पड़ेगा ना यार, मतलब बार बार सर आएंगे विजिट करेंगे।
नहीं लेकिन कल फिर सर अगले वीक में आएंगे, इससे वो तो जो प्योर सी हार्डवेयर कोडिंग है वो नहीं सीख पाएंगे अपन, मतलब अगले वीक में कुछ और डिस्कस होगा मे बी पॉसिबल। ये जो बता रहे सर वो मतलब प्रोफेसर नितिन सर ने किया है मतलब डिस्कस वीक 3 में, लेकिन इतना मतलब जो डिटेल में नहीं किया है, बस उन्होंने एड्रेस लोकेशन वगैरह थोड़ा सा मतलब ओवरव्यू दिया है कैसे सी कोड को रीड करते हैं हार्डवेयर लेवल को, बाकी कुछ दिया नहीं है। तो ये सर अच्छे से बता रहे हैं कि भाई स्पेसिफिक मेमोरी लोकेशन पे 4 ऑफसेट करेंगे, इस पिन को हाई करना है, इसको लो करना है, तो अच्छे से समझा रहे हैं, लेकिन पता नहीं नेटवर्क इशू हो रहा है उनके भी।
नितिन सर वो क्या नाम है, हो सकते हैं प्रैक्टिकल नॉलेज नहीं दे रहे हैं ना, मतलब वो सीधे सीधे वो दे रहे हैं हमको
नो
बता रहे
नो प्रोफेसर केवल ओवरव्यू दे रहे हैं, मतलब कैसे
हैं।
क्या
हाँ
राइट करना, बाकी इतना डिटेल में नहीं बता रहे जितना ये सर बता रहे हैं कि जैसे।
प्रैक्टिकल का ये सब बता रहे हैं ना आराम से।
हाँ हाँ हाँ।
Hello.
यस सर।
So actually, I've connected on the another laptop. So but that laptop actually not touching it any
ओके ओके
something.
ओके सर।
So and looks like it will not complete today. Okay, that laptop is totally now shut down.
ओके
Okay, so maybe that only the some part was pending to complete that code. I'll what I'll do that I'll paste the code that code which actually not completed on the forum. Okay, so actually what I do, let me just turn on again. So suppose if it give me a 2 minutes. Check if it will work. Hello.
Yes.
Hmm. Yeah, disconnected. So one second. The software again. STM32. Okay. So meanwhile, connect this. Wait. Okay. So yeah, the bitwise operator and this AND operator basically launch also. So here, if suppose OR operation, we want to perform some OR operation, and this is the first bit I am writing like A, and second bit is B. So if both bits are zero, okay, output will be zero. OR means if any input is high, output will be high. Okay, so 0 1 0 1 1 0 1 1. If we are performing OR operation in these bits, so that means any input is high, output will be high. So 1 1 1. Okay, so this is the OR operation, and AND operation is like this bitwise operator, and this is if any input is low, output will be low. So 0 0 0 1 1 0 1 1. Okay, so for all these situations, 0 will be output, and this is the one output. So this is the two operation we have, and we have also one that invert operation. So that is not operation basically that we use like this. Suppose if we are performing this with A, and A is actually 0, so this will become a 1. Okay, invert the actually input. Okay, so 0 to 1, 1 to 0, like this. Okay, so if we have suppose if we have 1 1 1, it will become a like this 0 0 0. Invert all the bits. So in this way, these three bitwise operator we have that performs on the operation on bit actually. Okay. So sometimes we will write a decimal value with the OR operation, but that operation will only perform on the bit representation of that decimal value. So so in last week too, if you have done that graded assignments, because of that we ask that type of questions bitwise operator. So if you want to set suppose that some specific bit, like you have some 8 bit 1 0 0 0 1 1 0 0, like this. So 1 2 3 4 1 2 3 4. Okay, so this is the 0th bit 1 2 3 4 5 6 7. Okay, so I'm giving the example of 8 bit, but in general we use the 32 bit, so you can that expand that in the 32 bit. Okay, suppose we have this bits in some register. Okay, so R1 registers we have this bits actually predefined, but our purpose is here we want to set suppose this bit, okay, this second bit from the right to 1 high state. So how we will do this? So we will just write, we will find a corresponding value like this 0 0 0 0 0 0, and corresponding that value which we want to set 1, only 1 and 0. Okay, so we will use this as a mask, and we will perform OR operation between R and this mask. Okay, so after OR operation, the all bits which are actually not corresponding to this one will remain same. Okay, so this will 1 0 0 0
Sir,
1.
here mask means intended
Yeah,
intended.
you so this is actually we are taking another value, another binary value to perform the OR operation. Okay, so that will perform the OR operation with the actual value of the register, and which bit actually we want to set means make as a 1, corresponding that value will only we will set as a 1 in our that another value of this. Okay, for the OR. So now we will perform the OR operation. So you can see if any input is high, output will be high. So this bit actually you can see this is high. So if corresponding bit is 0 or 1, doesn't matter, this will become a high due to this one. So now this will become a 1 and this is 0. So you can see previously it was 0, but now it is set to 1. by this operation, or operation. Okay, so in this way we can in this way we can set any bit to high state.
In this way, we can give the value to mask any value, na? Like here,
You
2 is
can
there.
no, which actually which bit we want to set corresponding, we will decide the mask. Okay, suppose you
Sir,
want
we
to
have to give the value according to the question and put
yes,
and or according to the question.
yes,
To
yes.
make.
Okay, so what is actually our purpose? So here, suppose if we want to set these both value to 1, so what you can do, you can perform one time this operation with this bit, or you can again take the or operation with like this, this 0 0 0 1. Okay, then your task will be done. Otherwise, what you can do, you can find out this mask as like this, 0 0 0 0 and 0 0 1 1. What is this value is actually in the decimal 3. Okay, so that means what you can do, you can perform R1 or operation with 3. Okay, so now this 3 is will become a equivalent binary of this form, and corresponding these 2 bits, now the first 2 bits or operation, these 2 bits will become a high. So like this, when you will perform the or operation, so this 2 bits, first 2 bits will become a high, and your overall output will be like this, 1 1 1 1. Okay,
So,
like
sir,
that.
remaining bits are changing. It doesn't matter, na? Remaining bits will change. Doesn't matter, na?
No, we will not change the remaining bits. Okay, maybe some other bits have some specific task. So do not change any other bits if you are not performing any operation on that. Only you update the bits which is required for your task.
Yes, sir.
Okay, maybe some other bits are set to 1 for some other purpose. Okay, so that should not be affected. So if your task is to just only update these 2 bits, only update these 2 bits, do not change the another bits. Because of that, we are performing this or operation, so that 0 corresponding bits are not updating. Okay, only one, this bit will be updated by this one. So because of that, we are using, so this or operation is used to set the bit. Okay, set the bit to high. And another bit, we have AND operation. So when we can use the AND operation, suppose we want to so now the problem is how we can reset the bit. Okay, suppose you have 1 0 0 0 and one like 1 1 1 0. Okay, suppose this bit you have in the one register R. Okay, now you want to set this bit to 0. How you will do? Okay, now you cannot perform or operation. Here you cannot perform or operation, like if you set this corresponding 0, still it will be 1 with the or operation. Okay, so here you have to use which operation? AND operation. Okay, so how? So now this time you have to use like this mask like this. Okay, so 1 1 1 1 and this bit 0 and this 1 1 like this.
So we will use 4 and with and.
Hmm?
We will use 4 with and operator.
No, 4 not, because what are the remaining bit will be then 0, but your other output will be become change. Okay, suppose if you take 4, so 4 means 1 0 0. Okay, so no, then how your task will be done? Our output should be like this. Okay, so 1 0 0 0 1 0 1 0. Okay, after we only want to set this bit to 0.
Okay, sir.
Okay, so what we have to do, we have to figure out this mask.
Okay, sir.
Okay, now perform the AND operation in between. So 0 1 0. Okay, 1 1 1 1 0 0 1 1 1 0 1 0 0 0 1. You can see all bits are same, only this bit is changed to 0.
Okay, sir.
So in this way, we have to figure out that how we can, if we want to set, we will use the OR operation. If we want to reset, we will perform the AND operation. But we have to figure out this mask, how we can figure out this.
So, sir, in the programming, the corresponding decimal value of this, we will have to input in that number and less than left side to
Hmm.
how much
Okay.
bit we have to shift.
So my question is how you can figure out this value.
Okay, sir.
This is difficult. So what is the how we can do? Okay, so I'm just telling you. So now you want to set this third bit to 0. So what you can do, you can perform, you can take 1 and just shift 3 times. Okay, so 3 times. So what will it will become like a, so suppose this is a 8-bit register, so this will become a 0 0 0 0, and after that 0, and then 1 0 0, correct? Because the one was
Which number are you changing, sir? R value. Na?
Three left,
no,
three
I
left
am
should.
so I am performing this operation only one. This is the actual decimal value. Shift 3 times to the left. Okay,
Yeah. So
so that is
three
actually
times
0.
left, then it will.
1.
Yeah,
Okay.
1000.
So this was the actual value 1. Now shift 3 left side. Okay, so 1 means okay 1 2, okay, so 2 times. Okay.
No, so two times. No, yeah.
2 times. Yeah, so 1 time and then second time. Yeah. So in this way, this will become a 0 0 0 0 0 0 1 0 0. Correct. After
Okay.
that, we will perform AND operation. Okay. So after
Okay.
that, we will perform AND operation, and then it become a 1 1 1 1 1 0 1 1. Okay. Now you can see this is the same, and we will
Okay.
perform the AND operation with this.
Sir, one question is more. If we want to change the 2 bits, then we will this grade less than we will put I think 3.
So in this case, suppose if you want to set 2 bits at any position, okay. So what you will take 3, okay. 3, then how many times you want to shift that 3? So suppose you time to shift 4 times. So for 3 value is like 0 0 0 0 and 0 0 1 1. Correct. This is the 3. Now shift 4 times. So that means this will be shift 4 times. Okay. So 1 2 3 4. So our output will be 0 0 1 1 0 0 0 0. So you can see this 1 1 is shifted to this position. Now you can use this for OR operation, or if you want to reset to 0, then invert it. Okay, invert it. So it will become a 1 1 0 0 and 1 1 1 1. So now this becomes 0 and perform AND operation to reset the value. So in this way, you can set your bitwise operator, how you can want to reset or set things. Okay, so this is just an example, and just let's complete that. So let me open where we was actually. All code is deleted. So check. Oh, our previous code is actually deleted. We did not save that. Then we have to start from the again. As include. Okay. So now we subset like uint and 32 e and some that what was the, we have to check all the registers again. So let's open the documentation first. Embedded C, 1 second. Yeah, someone mic is open. Okay. Okay. So we have to write the code again. So what we have done. So for first is that RCC control. So that let RC control or let's write a small code. Okay, RCC. So RCC, this is a pointer actually. So equal to, and what was the address? First address of this. That actually. Looks like today 3-hour session. So what was the RCC? Yeah, this one. Okay. So, this is the hexadecimal form, but if you remember that for that GPIO, we have find out 4C into this. This is the offset value, and this is the typecast we require. So uint 32 and T. So this is for RCC registers. After that, port A register, and I'm writing like port A. So this naming is also important. How you are giving the naming of variables, which you can understand later. So I'm writing right now. I'm writing short name. Okay, so to understand that and another is PA, so that data PA data output. Okay, and the address was again. So this was the initial address. Where is the GPIO port? Yeah, this one. So this 48 6 times 0. So 48 and 6 times 0. Okay, so this was the first register. After that, we have added some another register value. So that was, I think, so we have to check again. So general purpose, and this is GPIO, and no, this is GPIO registers. So you can see that GPIO output register is input and output. This one, 14. So 14 add in this. Am I audible?
Yes, sir.
Okay, fine. Okay, after that, what we did actually, we set this RCC for first bit. So we perform the OR operation. Okay, so that OR operation is simply state line equal to, and this is 1 with left shift 0, or we can leave 1 also. Okay, so no problem. So that is also fine. But otherwise, just make a practice to use this left shift, right shift to perform things. Okay, so this is enable the GPI port A. So now this is done, and to set this actually we will perform. So how we will set this? So as I said, this what we need to set for this register is actually yeah, this is the register. Now GPI port, this is the first one. Yeah, this one. Output this output mode. Okay, this one. So we need to set this 10 and 11. Okay, to 0 1. So what we have to do first, we have to make this 11. Okay, make this 11 to 0. Then we have to make this 10th bit as a 1. Then our task will be performed. So how we can make this 11 bit?
Sir,
Yes.
sir, where these instructions are given, sir?
In the documentation, the reference manual.
Okay, sir.
Okay, so all these that memory mapping, register address, bit mapping are given in the reference manual of the board. Okay, so now in this registers, actually this is defined the pin mode. What mode we are actually using for the pin? We are using output mode. So this mode. Okay, so we need to set this 0 1. So we are actually using the pin number 5. So that pin 5 is actually representing mode 5 here, and we will set this 11th pin as a 0 and this 10th pin as a 1. So how we will do this? By the bitwise operator. So what we will do first, first thing we will reset the 0. Okay, so this is AND operation required. AND operation required, but which value actually? So that is actually a 1, and shift how many times? that 11 times, correct? Okay, so yeah, 11 times, and after that make this as a that reverse. Okay, so because we invert, yeah. Okay, so we are performing this, we want to set that 11th pin as a bit as a 0, so that is done by this. After that, what we will do, we will now set the 10th bit as a 1, so that is actually a 10, and this is OR operation, uh, OR, and this is not required now. Okay, so by two operation we have done this. So we have set 11th bit as a 0 and set 10th bit as a 1. So now this is done. So this is for mode selection. And now again what we will do, this data. Okay, so this data is actually a main part. This is actually a output data, so this is fine, so no need to set this here. Now what we will do, we will want to turn on or off our LED. So we will take some flag like this int flag, one normal variable. Okay, so this is, we are setting to 1. So this is just indicating a that our LED is on. Okay, now we will run a loop. So while, and this is a infinite loop. Okay, and this is an infinite loop. Inside this loop we will check the flag value. If flag equal to 1, then what we will do, we will reset the data value to 0. Okay, so this p data, now this field value, so because our uh, pin number is 5, so let's see what, how we will set this. So just see the document again, and this output data register, so that output data register is this one. Okay, uh, no, output speed registers, and this is input data, yeah, this one. Okay, so this pin, okay, pin number 5. Okay, so that means you need to shift uh, left shift to 5 times. Okay, so this bit we need to set 1 to high mode. Okay, and to 0 to low mode. Okay, so that things we need to do here. So in this way what you can do, if you want to shift that okay, so let, I'm making this as a to set. So this is OR operation, or equal to, sorry, 1 how many times, 5 times. Okay, pin number is 5. So this is done, and other condition we will check, if this is 0. Okay, let's make this as the different 0, and this is 1. So if 0, then we will make high, and if this is high, then we will make as a low. So how to make low? So AND operation, so that is and this is the invert. Okay, so that is invert things. So now this will make as a low. Now thing is, this is actually making a LED high, turn on. This is making LED low, but there's no time delay in between. So how we can add the time delay in this operation after this perform? Okay, so how we can perform the time delay? So we can add a just simply a loop. Okay, so we can run a loop like this for, and we can take like a int I, and we will just set some value to 0. We are running is just a additional loop here, and that is started from 0, and we will set some high value for this, that is looks like 1 lakh. So we'll see that how much interval we are getting by this, and I plus plus. Okay, so this is simply a empty loop, and with continue, so this will provide some actually delay. Okay, because this operation will take some time. So now this operation is running, and let me connect my board again, and we'll turn on the camera. We'll see. So you can see I am only using the pin that 5. Okay, not this time this pin. Let me just turn on the camera also. Where is the meeting link?
In the program, some extra quotation came, sir. Please delete, sir.
That I'll delete. Okay, so you can see microcontroller is running the previous code. So that yeah, this is also done. So looks like our code is complete. So this is okay. This is okay. This part is okay. Flag 1. This is 1. Oh, we are okay. We have not set update the flag. Okay. So after get entering into the conditional statement, if our flag is 0, we will set this at a 1. So to just change the state, otherwise it will remain same always. So that is now this and this to 0. Okay, so now this is also done. So let's do things. Let's save this first. After that, just build this. So let's see if any error is coming. Okay, some warning is coming. So what warning is there? Uint 32. Some pointer issue is there. Okay, so we have to use the typecasting. Okay, yeah, that is. So for typecasting, because this is the pointer, so that we have to make this. Let's see this. Okay. Oh, this is simple assignment operator. Project. Yeah, now this is correct. Okay, no error. And then upload this on the board and let's see it is working fine or not. Okay, so only one time this LED is turned on. After that, it is not turned on. So let's see what is the problem. If it is flag 0, that flag 1. If it is flag 1, then it is to reset to 0. And 0, that is while loop. Oh, let me change the state to 1. So this is not changing the state. So what is the possible issue here?
Can we use the else statement for if loop, the second else if?
Hmm. Else if. Okay.
No, only only else is sufficient.
Okay, we have to change this also. Yeah, correct. This is also a possible 0 and 1. Yeah, correct. So, build project. Oh, yeah, this is working. Yeah, what happening actually? If flag was 0, we are setting to 1. Then next condition is also true. So that is actually entered into the both condition in the every time. So yeah, this is fine. But you can see the blinking speed is very high. So let's increase one more 0 here. So let's again that build project and that run again. Now you can see blinking speed is approx 1 second. So here now this code is working fine. Okay. Now if you want to turn on another LED, so what you have to do, you have to actually enable the first thing, you have to find out the address of that pin. Okay, so let's try that also. So here if we will take another pin, that is actually a B mode. Okay, so I'm writing B here, so B and B, and this time here we have to set second bit also to true for RCC, because A mode is representing the first bit, B mode is representing the second bit. So what we will do, we will take 3. Okay, so now both bit will become high. Okay, so in that case RCC will be enabled for both mode, B mode as well as the A mode. So but we have to also set this mode to the another pin B. But okay, one more thing, we have to also check the address, initial address for this. So that B address is starting from, so let's see that memory, a system memory, and see where the GPIO mode B is started. Okay, so GPIO mode B started from this location, only 400. So that is the only change. So 400. So 400, and this will become a 414. Okay, so address is the register address are same offset. Okay, so what is the initial address? We will find out the other address. So now this address is changed. So that means we will update this field here. So that is B actually. So B, and now this B, and pin number we are using the same. Okay, fifth number pin on the B mode also. So now B is set, all mode is set, now only here. So we have to only update the, we will write like this. Okay, so for data, so this time not here. Okay, so this is now B pin, and B pin actually is reset to 0 this time. Okay, now A pin is actually high and this is low, and this side we will copy this port, okay, to 1, and this is B. Okay, so I hope the code is done for the second LED. So all things are there corrected. RCC is enabled, mode is enabled, and data is updated. Okay, so let's build this, and after that, okay, where is the data coming? Yeah, this is succeeded, and run. Now it is uploading, and then see, yeah, you can see now both LEDs are turning on or off. Okay, so same things we have done in the
flip flop, sir.
Hmm?
It's like a flip flop, I think.
Ha. So one state is high, another state low. So in this way, this is working. Okay, so you can set your task with the LED, what type of behavior you want to do with this. Okay, input output things, and you can also try to push button. So you can take push button for the input. So I think that I'll explain in the next how we can get the input, and based on the input we will return the output. So only very little modification are required, some setting is required, so that we will do. Okay, so already due to my laptop, already the session is extended too much. So I hope you get some idea of the real hardware coding. Okay, so this is actually a real hardware level coding where we are directly working on the memory locations on the each component, that RCC and that GPIO, and we are changing the value on directly memory. There's no direct that is hidden method we are using. Okay, we are completely code is written in the C. So I hope this is clear to you a little bit. Maybe you, if you will practice, then you will also understand that. Okay, any query in this code?
We have to look into that, sir.
Okay,
The arrow
so
portion is not clear. That we have to.
so arrow portion is simply a bitwise operators, left shift, right shift, or and no. Because of that, in the previous session, I mentioned that this bitwise operator is very useful operators for the embedded C. Okay, so just practice on that, how they actually this works. Okay, so yeah. Okay, so we'll see in the next lab. Okay, so what we will do, we'll decide. Okay, anything else?
No, sir. Now we can leave.
Yes, you can leave. Yeah,
Thank
thanks.
you, sir. Good night, sir.
Okay, good night.
Thank you, sir.
Okay.
Garba night.